Hi everyone, happy Monday. Welcome to our workshop for today. I'm just going to give it a minute or two to make sure people have enough time to come. But yes, good morning, good afternoon, good evening to wherever anyone is in the world. Lovely to see you all again. Yeah, can't believe it's already week 3 of the hackathon. It's gone super quick. But no, yeah, really excited to see what everyone is currently building and how things are going on. But yeah, I'm just going to give it last minute or two to let people in. Hi everyone. Hi everyone who's just joined. Lovely to see you all. I'm just going to give it again one last minute before we get things started. Just a quick note from me. It'd be great. What's it called? Sorry. Yeah, of course, use all the links in the chat as per usual. I'll be sending out again. So the technical questions chat and also team formation. If people are still looking for teammates, please do let us know. We are more than happy to kind of help match people to right teams. Amazing. Hi, everyone. Welcome to today's workshop. Today with Boris again for our exciting workshop to start things off on week 3, which is elevating player experience, mastering account abstraction in Solidity for game development. So without further ado, I'd love if you could kick things off, Boris.
Hello everyone. Hey, Ohana. Thank you. Let me start sharing. Okay. So first, uh, we are doing account abstraction. We will talk a little more about this, but every protocol based on their infrastructure or their development process implements account abstraction different ways, right? So we will be focusing. I will give a quick intro where we talk about how Ethereum is doing it, but it's not necessarily it's not the same way Aurora is doing it right now. It's not that it cannot be done this way in Aurora, but you will see later why. But let's talk a little. Let's start from the beginning. What is account abstraction, right? This is there are many. You will find many definitions about what account abstraction is, but I wanted to keep it simple. An account abstraction in general is a proposal or a way to do things that enables to use smart contract wallets instead of externally owned accounts. If you took one of our first workshops, you will know that externally owned accounts are regular accounts that users like you and I get in comparison with the smart contract account, right? So these are the ones you get when you open a new MetaMask account, for example. So what this allows is, a smart contract. We will talk a little more about this later, but smart contract cannot sign transactions per se. So this creates an abstraction level. The idea is to create an abstraction level so a smart contract account can actually execute transaction in behalf of an EOA, of a regular account. The basic idea is that the user can use smart contract wallets instead of EOAs, right? So what is a smart contract wallet? I will talk a little more about that. So this is just it's a smart contract actually that have the functionality to act as a self-custodial wallet, but it's a smart contract. It's just a smart contract. So this way, the wallet instead of having your address, it will have the smart contract address. So it eliminates the need for user to manage their private keys directly. This is this part is a little subjective, right? You still need some keys, but for executing a specific set of transactions, you don't need the keys. I will talk about it later. So why account abstraction? Uh, you don't need an EOA to execute transactions. Basically, that's the so me as a person. At the end, it will be an EOA, but my account, I don't need it to execute a transaction. We can detach the account from the keys. Um, you can set it so it's no fees to pay for this because so a third party will take over of the fee for you. Again, we don't the user doesn't need to manage the private keys, and the user enjoys the benefit of self custody. We'll talk more. So the Ethereum approach, I will talk a little a short history about what is going to happen. This is relatively new, even though they've been talking about this for a while, but only last year it picked up. So they have released a few proposals for improvements. So they have the 86, the 29, the 2938, the 3074. Only recently, the ERC 4337 was authorized, approved as a solution, right? This is decentralized. It's basically they have something called bundlers and paid masters and a lot of things, but the basic idea is that you send your transaction for someone to someone else, and that someone else will bundle a lot of transaction and will pay the gas for it, right? It's like someone in the middle that will pay the gas for your transaction. So you can get an agreement with that person in the middle, right? That person in the middle will probably charge you for that, but you don't necessarily charge. Let's assume you have a game and you have a dApp, and you don't want your users to pay for this, for any transactions they do. So the bundler will take care of those transactions, and you pay the bundler whatever he's charging you, but you don't necessarily charge your users to do this. So they are in the middle, and they take over of the transactions and pay the gas for you. So that's the general idea. So what Ethereum did here is they created the specifications for how the bundlers, I mean the nodes that will take the transactions, and the paymasters that probably will be in your case is if you have a game and you're the dApp, you will the paymasters. So they create specifications for both, for the bundlers and the paymaster, and how they should interact with the users. So that is what ERC 4337. It was been talking for a while, but Visa wrote a short, let's say, white paper that said that they could see this as a solution for subscription, right? That's an issue that you, especially for games, you will be able you will face eventually, right? Let's say you want to let you want to charge your players, the gamers in your game, I don't know, monthly or whatever, weekly or whatever. So the way you do that today is that they need to connect to your game or whatever application you have. Let's say it's a game, go to the MetaMask and say pay, approve a transaction, etc., etc. With this approach, and that was this was a Visa white paper last year. I can't remember. It was like last year. It was relatively soon. They say with this we don't need to do that. We don't need this a way so the user doesn't have to log in and pay. They just can say to me, I want to subscribe to your service for 1 year, and you can charge to my account once a month. And my account it won't be an EOA account because that cannot happen. But I do have a wallet, a contract account, and an abstracted account, and you will be able to charge it there. So that's what Visa was proposing, and we're actually asking for developers to expand on that. And this is possible with with this, right? Basically, one approach, one simple approach could be, we'll talk a little more later about this, but it's that probably when you subscribe, you pre-sign 12 transactions, and the in this case, the bundler will execute the transactions once a month or something like that. It's not clear. I mean, they didn't say a specific solution, but you will see later today that it's possible to do it using account abstraction. So let's talk a little more about how account abstraction in Aurora will be. There are two approaches. I will also talk about a little more about the future, how this can be easily upgraded using Aurora Business Borealis. But let's took some basic approach. We will use meta transactions and we will use Aurora Pass, right? So let's talk a little about what are meta transactions. Meta transactions are, you know, contracts cannot, as I just said a few minutes ago, the contracts cannot sign transactions or messages. They cannot sign anything because they don't have private keys, right? When you deploy a contract, you don't have a private key for the address of that contract, right? So only EOAs have keys, so they're the only ones that can sign a transaction. So if I assume you are familiar with its transaction signing process, but if not, I will be a quick intro. Will be you need you to say that you are approved to run a transaction. So, for example, you want to pay someone, you want to send some Auroras to someone else, and you have some Auroras in your account, in an EOA account in MetaMask. You need to say, okay, I want to send these tokens, I don't know, to Johanna. This is my private key, and I use this private key to sign my transaction, to say, this is me, and I approve this transaction. They send this money to her, right? So that's in general terms. I'm generalizing a little because it's a complete another topic, but that's the basic idea. But even though the contracts cannot sign, they can verify a signature. So I can send some information to the contract and say, this is a signature from this public account. This is Boris public key or account. This is Boris. This is his Aurora address. Can you verify that he's actually, and this is a transaction? Can you tell me if Boris did actually sign this transaction? The contract can do that, and we will see that on the code later. But the contract can actually do that. So they cannot sign it themselves, but they can definitely verify a signature. So if you want to have a transaction initiated on behalf of a user, you can use what we call a meta transaction. It's like the user signs a transaction. You say, I want, imagine they want to interact with a gaming contract. The gaming contract allows you to buy a new weapon, whatever, an NFT. So they approve that transaction, and then they send that transaction to a third party, and the third party pay gas for it. And the third party can verify. They say, okay, Boris sent me this transaction. He wants to buy this weapon NFT. This is his public address. So let's verify. Yes, if this is Boris doing this, I will run this transaction in behalf of Boris, and I will pay the gas for it. That's the general idea of the meta transaction. That is called a meta transaction. Again, I'm simplifying a little, but that's the general idea. I sign the transaction, I send the transaction to a third party, and the third party verifies that actually is me doing this, and then I execute the transaction, somewhere else. It could be another smart. It should be another smart contract, right? So how the third party pays for that gas? I mean, in the case of Aurora, it could be they just pay for the gas, and then they charge me later and say, okay, I pay. I mean, not Boris the player, but me, I don't know, the game developer. They say, okay, you game developer, Boris bought an NFT. He sent us the money, and the gas for this transaction was cost, I don't know, 1 cent, and we pay for it. Please give me that money because I pay for that. Usually, he will probably have prepaid. You have some balance there, so that will be the general idea. So, and then you, as a game developer, you can say, oh, Boris, you did this transaction. It costs 1 cent. Pay me half of it. Pay me nothing. Pay me the whole thing. Pay me more. You decide that. So as you see, we're creating some abstraction levels in top of this, normal EOA transaction. So that's the general idea of the meta transaction. That is one approach you can do in Aurora. We don't. I mean, the 4337 hasn't been implemented per se, so there are not in the Ethereum case. This person that takes a transaction and tell you that someone paid, etc., is called the bundler. So they are not bundlers per se. As far as we know, there are not bundlers doing this in Aurora. Anyone can do it, but it's not like a thing happening. So you will have to find someone to do it, or you can do it yourself for the players. But the concept is the same. The concept is the same between Aurora and Ethereum. The difference is that Ethereum created a whole, let's say, a specification for infrastructure that will allow to third parties to profit for it, right? You say, okay, these are specifications, so you can become a bundler. You can send meta transactions in behalf of another, and you can charge them for that. So this is the right way to do it. So that's in general. And again, I'm generalizing a little, but that's a general idea. And in Aurora, there's no one doing, as far as we know, 437 but those specifications can, I guess most of it can apply for Aurora too, because it's VN compatible. But you don't have to do it like that. You can implement your own system to become a bonder. Let's call a bonder, become a meta transaction processor or something like that. So how this work is the front end. I mean, the user. It could be this many ways it can be done. The user signs a transaction somehow. You create your own interface. You get the user to sign the transaction, and then the user sends you the transaction to an API. Right? Is in theory safe because the transaction. In theory, no, it's safe because the transaction is encrypted. The private key is not traveling. Just the signing transaction. So I receive the transaction is a piece of code, it's hexadecimal code, and I myself send it instead of letting the user send the transaction. I send the transaction to a wallet contract. I will pay for that gas, and the wallet contract will verify the signature, all the things we just talked about, and then the wallet contract will execute that transaction. This way, I pay for the gas, and the user just send me the signed transaction. It's just like saying, I'm signing this transaction. It's like sending a check. You go and cash it, right? I just received the signed check. The process of verifying that the check was correct. I don't know if you're too young to know what a check is, but I assume they're still around. So it's like I signed this paper. You tell me it's money, this paper, so I verify that it's true that you have money, etc., etc. So this is how it works in general in the backend. Again, if you have any questions, it gets too dense, just ping me here. I'm happy to go back and repeat whatever. So the other way we can do this in Aurora is using, this slide was created called Aurora Plus, but Aurora Plus is being phased out and moved into Aurora Pass. The general idea with Aurora Plus and Aurora Pass is that you can get free transactions. You create an account in Aurora Pass and you don't pay gas for that, for a number of transactions, like 50 transactions, I think it's right now. So the first transaction, or you can just don't pay for gas for it. So the idea is that instead of getting the user to send you a signed transaction, because you don't want them to pay for the gas or the final transaction. This is a point here, right? In this meta transaction here, the user is signing the transaction, so they might need pay some part of the execution gas. They don't need to pay the execution with the wallet contract, but they might need to execute the one in the contract side. In this case, what you're doing here, you do some kind of you authenticate the user using, I don't know, OAuth, a traditional Web2 authentication process. And from there, you just tell me, okay, I know this is you, Boris. Send me what do you want to do? Oh, I want to call this transaction in this contract. So you use a wallet contract that is funded by a, a wallet contract that will pay the gas using the EOAs of Aurora Pass that is free, right? I will show that a little later. But the idea is this: the wallet contract will pay with the gas with the sender, with the message sender, and the sender has zero gas because they have Aurora Pass, so they can run the transactions that way. Um, so this is simpler than the other way. You don't have the user doesn't have to sign the transaction, and is you are is a it's not a meta transaction per se, but you are creating like a push meta transaction or an abstraction over the account of the meta transaction. It's like another level of abstraction here. So that's how we this is another pass, another approach with Aurora Pass. So what happened here is you have the web to out, and you just send the transaction data to the wallet contract and say, and the wallet contract receive someone, it's sent to the transaction to the wallet contract, and the wallet contract will pay for the transaction using an Aurora Pass account that have zero gas, so it won't pay gas. And this happening in the backend. So once the backend has the transaction data, it tells the wallet contract, please execute this the other contract, the game contract is called here. Let's you execute this transaction in the wallet contract, and yeah, that would be the end of the process, right? So what these are the two ways that can be done right now. There are other options doing it here. So near, as you know, we are layer 2 for near. um we they have an account model that is allows to delegate transactions. Basically, it's the same what we talk here. So you sign the transaction and say, but you don't sign the transaction per se, you just approve a delegation. You basically say, okay, this another account can pay for this, should pay for this, and the account is agreed to pay for me. So you can do that. So another approach could be, since we don't have a lot of time, I won't go through that one, but you can once you can deploy a new contract, and using what we talked the last workshop, the cross contract calls, you can call the near transaction and tell them, okay, pay for these transactions. So that's another approach using near. It's it has its own complications, but if you want to go, if you already have your contracts in near, or you want more information about that, just let us know and we can talk with you about it. Another way to do this, and this will happen in the near future. Aurora just launched what is called Borealis Business, and Borealis Business, what allows is to create rules inside where you say all the interaction with this contract are free, or for a specific whitelist. So instead of having to create like an Aurora Pass, you can create a rule, Borealis Business rule, and say I will pay for gas to every interaction from this contract. I will pay for it. So that's something that it could be done. So the code I'm about to discuss, yes, we can have a copy of the deck done, no problem. Yeah. Um, uh, what I was saying, okay, the code I'm talking about, it covers both approaches, the meta transaction and the Aurora Pass transaction. And the Aurora Pass transaction, if you work with a business account, Borealis business account, it will be similar code. The codes are, of course, simpler that it probably could be, because no, for a demo here, it doesn't have all the security considerations, but the general idea is there. So let me switch to the
Oh, Boris, just before we get started in the code, I just got a question from Bernardo, if you don't mind.
Yeah, sure.
If the user does not have to sign the transaction, how does the contract wallet know it is the owner who is sending the transaction?
Yeah, that's I talked about a little before, but the idea is this, that you can let me go back to the no, Aurora has been trying to make this easier for Web 2. So the way you can do this is here, that you authenticate your user whatever way you want, right? you, I don't know, OAuth, or no matter how. Even it could be, a Web3 authentication user using device authentication systems like, I don't know, their face or whatever. There is, you authenticate the user. You find a way. You are a traditional Web2, or you want to keep the traditional Web2 approach. So you authenticate the user, and then you create your Aurora Pass account, or your business account that doesn't pay gas. So you start transaction in behalf of that user, but you do the authentication. So that's what I call it, like a poor man abstraction account, because at the end, someone have to actually sign the transaction. It's just you decided to decouple that. You say, okay, I will authenticate the user. I will take care of it. I have a mobile app, and I use the Apple's secure element authentication. So I don't want them to sign transactions, because these guys doesn't know how to use MetaMask, or I don't want them to learn how to use MetaMask, because it's too difficult for them. So I will authenticate it traditionally, and then I deal with this. You with the normal approach is, you tie a web out or OAuth token to a EOA account. That could be a little, it's complex, but it's been done. You basically tie token, OAuth token, to a EOA account or something like that. But that's the gist. You authenticate the user, and then you are abstracting the account on top of it. You say, okay, I will handle this. I don't become a custodian, because the authentication it stays in the user device. Doesn't have to be like that. Could be in the backend, but it could be an easy, so you don't become a direct custodian. So, but that's the general idea. I don't know if I answered your question, but that's the approach I'm taking here. Okay, so here I took, let's see, in the code here, I'm taking the two approaches, right? Let's start with the method transaction. Where is here? Wallet contract here. No, with the meta. So the meta transaction, what does this contract do? This is a wallet contract. To this wallet contract, you can send a contract in bytecode. We discussed this. This is the same I used in the previous workshop. So you send the whole contract in the bytecode, and it will deploy it for you. So how you do it? I showed it the last time, but basically you use the ABI. I can show it later, but you use the ABI. I don't know, either some Web3 ABI functions, and you send the bytecode of the contract, and the wallet contract will create that contract for you, and it will store it actually. Once you call the create contract, you send it by code, and it will store it and keep track of the contracts you deploy, right? So the idea is, like, say you have a simple contract that whatever it does. This is a very simple, just has a list of the blocks of blocks. It's very simple. So it adds the current block to an array. So this is just for doesn't make anything really, but is to show functionality. So you can call the factory, you deploy the simple contract, and then you can call the factory. You can send a signed transaction here to this execute method transaction function. When you just set the RSSB, I just definitely don't have enough time to explain this whole part, but these are and you can read about it, and we can probably talk later. You can ping me. This is how you send the transaction to be verified. So basically, you send in the signature, you send in all the information they need to execute a method transaction, and you have to send the function signature. So you're basically saying, I need you to go one of these contracts that I deployed here. It will be called is a simple contract meta. I want you to call the update function. This this is the transaction I signed, and please execute it for me. This is basically this is doing, right? So this wallet contract can create new contracts, and then can let you interact with these contracts, and you can make it so it's free for the final user. It depends on who calls this execute method transaction, right? you can have your own backend to call this executed transaction. So you pay for the whole thing. And this way you are basically abstracting the account of the user, and the transaction is called from the contract. So the contract is becoming de facto wallet. In Ethereum, this process of executing this executed transaction function is done by the bundler for a third party that gets paid for it. So they bundle multiple transactions, and they charge people for running transaction for them. But this is the basic idea of a is it will be a simple wallet contract, but it's a general idea. The wallet contract will let you interact with any contract. You say, I want to interact this with any contract. In this specific wallet contract, you can only interact with the contracts you created through the wallet, right? So I create a wallet contract. I deploy this contract. I can only interact with the contract I deploy, but it doesn't have to be like that. You should be able to, probably you can improve this function, and you also set the address of the contract instead of having to bring them from a here. You don't have to send the address because it's being stored in this mapping, right? But you can make it generic. You just say this is the function in this contract, this is the address, this is the ABI of the contract. Can you please run this transaction for me? I'm signing this transaction for you, please run it for me. So that will be another a more complex contract structure for this contract. But in this simple example, you create a contract, and then you can interact with that contract and you pay the gas for this interaction. You can leave the user not to pay for it. So this is the traditional meta transaction. Well, I'll say traditional, but this is a meta transaction, simple, basic approach to create a wallet contract. The other wallet contract that will be with Aurora Pass is similar, and this is the one Bernardo, I think, he was the one asking. So basically, it's similar. The contract only interact with the contract they create, so it's the same. Create the contract. But to execute the transaction, I just need the data, the basic data. I don't need the signature. I just need the function you want to send me. You're telling me you want me to interact, and the data you want to send to that simple contract here. In this case, if it was this simple contract, this is for example. So basically, you will call the same update function. You will see a difference here, right? In the simple contract meta, I'm using access control here. So I'm saying this update can only be in the meta transaction example. The only one who can call the data is the sender of the whoever is calling update, right? Because he's the one who signed the transaction, right? I want the signer of the transaction to be able to do this. So it's different from the other simple contract. Here, I can assign the you see. Let me show it again. So simple contract and initialize. I can, since I want the transaction originator is the user who signed the transaction. When I initialize the contract, I need to give him a role. He has to be the user role. So I need to create, okay, this is a user role. He should be able to call this. So when I initialize the contract, I need to be able to give access to that user. This is very specific of this contract, but I do this to emphasize on the difference approach. In this contract is the sender, because in this contract, the one paying for the gas or everything signing, it will be the wallet, not the user. The user there is no signed transaction being sent here. So in this one, the initialize is simpler. It's just the sender. Whoever calls, whoever deploy this contract can pay for is the user. Is the one sending the transaction. So if we go back to this one, this is what's happening here. Basically, sorry, let me close it. Simple contract. Let me find it here. Here, the wallet contract. So this will execute the transaction here. So no signed transaction, right? So what is happening here is, at the top of you authenticate the user OAuth. Once you authenticate, you call this function on their behalf. And if you have an Aurora Pass calling this function on their behalf, it should be free for the first 50 transactions. Or you can implement a business deal with Aurora business, Borealis business, and then you can have different type of rules like this transaction would cost less, more would be free, etc., etc. So you can create those rules later. So this will be the different approach using. It will be simpler doing this in case you want to do it soon. I mean, for the hackathon, you can do this. You can just open your Aurora Plus account and get 50 transactions for free. So you will pay the transaction for the user, but then you have to authenticate your user. You have to make sure that the user knows. You create a user and password. But in this way, you are detaching the keys for the account, so the money is not directly affected. If the user lost their password, not necessarily have access to the money on the account. Can play the game for them. That would be an issue, but they don't have access to the money on the account. They cannot drain the account of the user if they do this. They can play for them, but they cannot drain the account, the funds in the account. So that's a benefit of both approach. The the both approach have. They will have access for some stuff, but they won't be able to drain. So I'm using this account to play, but I also have $1,000 in the account. If my password gets leaked, they cannot drain my account. They can play for me for a while, but they cannot drain the account. And then with more, you can add a whitelist here, for example, and then, or you can add a possible function in this. So probably if there is a big leak, you just pause the wallet contract, so no one can actually execute this transaction, right? Because only this contract is the one allowed to interact with simple contract. If I pause the wallet, no one, the password was leaked, you just pause this contract, and no one can interact until you fix whatever issue you had, right? So this detachment, this distance that you are created between the account that is transaction with the contract and the account of the user gives you that kind of security level, right? That you can contain the leaks, you can stop the whole operation easier than if you got just interacting with you directly through a MetaMask function, like a external public function here. So that will be one of the biggest benefits, right? There are two benefits here at the end: is simplicity, that you can enroll the user using traditional Web 2 in this case, or you just can but still, when you sign it locally, you need the MetaMask, right? So but it's simpler. In this case, you will detach the gas fee payment, right? So you will pay the gas for them using the meta transaction. In this case, you will pay the gas, and they will need to use MetaMask. So it make it a little more simple. Some centralization. That's the argument you will have. Are you losing centralization? That's true, but it depends on what your business model here. Probably you are not necessarily about the centralization entirely. You want to do it decentralized, but you don't want to. You feel comfortable doing so OAuth, right? I will put the because it's the same I give to for the last time, but I will let me commit and deploy for this one. Let me dev workshop same as workshop 2, workshop 4 update. So I'm doing the workshop. It's the same. Let me put it here. I'm still need to add some documentation to the README and stuff like that, but I will do that today. So I give you the link, and then sorry about the missing README, but I will add it later, and you can always ping me, and I can help you with this. I'm finding the link so I can put it here. GitHub. Second. And here, okay, I'm pasting here, so you will have it. That's a repo. It's the same. It has the same contract as the previous workshop I did. So the third party agents call the bonder, but this is the 4337 specification. This is a very specific for Ethereum, and the bonder definitely need to have a wallet, but it's not only a wallet. It's like a node. Imagine it's like a validator, right? It's like a validator, but they don't validate transactions on the blockchain. They just process transactions and pay gas for them. This is asking a question, question, right? So this is the idea. If you go to the EAP 4337, I think that's the whole name in Ethereum. They have the whole specification for that. So you can actually go ahead if you want. And I'm not sorry, it's ERC 4337. Yeah, so you can go ahead and try to implement it for Aurora. It should work. So I cannot delete that one. Ignore that one. It's ERC 4337. Oh, it's EAP. Well, it's there. You can read it there, but you can easily implement most of the same bundler, become a bundler, or but in Aurora, because is it's just calling EVM transaction commands and opcodes and the whole thing. This is the same. So you can read the specification and see how they work, but you don't have to do it. Actually, what I'm trying to do here in this code is to put it in a simpler way, so you don't have to go through all this. Probably as it is, it won't work to go into production, but you can work on it and make it secure, etc., etc. So that's the idea of this code. I'm running out of time, so but I can stay for some questions, whatever you need. I hear, and well, thank you. Sorry for there is some, I can talk about this longer, way longer. It's just so many information, so too much information, and so many things to talk about. So I don't have the time, but please ping us if you want to know more about it, if you need help with the contracts or whatever. I hope that at least you get the general idea of how you can approach this. This is something we would like to see in the game in any of the tracks. But as you know, Aurora, and if you've seen any of Alex's presentation, we are about making these interactions with the user simpler. And if you can use Aurora Pass accounts, free gas accounts, to make this user interaction for gaming or for anything, but gaming is a good use case, it will be better. It will be better for the game. It will be, and it will. We like to see that in the hackathon implementation. Pricing for which service for business Borealis? Are you talking about, Clint? If it's for the hack, this is something you have to. If you want to use it, you have to talk with one person of the team, or if you want to directly for the hackathon, we create a silo specific for that, and you have all the benefits that you have. All the transactions in the silo are for free, so none of the transactions pay. So is de facto our business Borealis rule already implemented for you. Just use the silo, everything is free. So you will like emulate a similar if you have a deal with the business Borealis. But if you want more information, you can ping me and I can put you in contact with the right person. This is my I will put it here. I didn't bring this one doesn't have the Telegram. This is my Telegram. I will always say when I put my Telegram, is I will never, of course, I will never ask you money. I will never ask you for a private key, nothing. So if it's me asking you for stuff, it's not me. They doesn't have to. I mean, the final user, you can abstract it out. You can make it, but you don't have to. That's what I mean with the OAuth authentication. You authenticate the user, you create your own logic because behind this authentication, right? You say, okay, I will do with OAuth, and with my JW token, I will link it to an EOA account, but the user will never see that EOA account. You just use it for your own, usage, right? You can derivate your EOA account from your JWT, whatever you want to do. So the user only have to log in using OAuth, Web2 traditional, and then you create the logic behind to interact with the use with the contract. I will suggest use free transaction, so it will be free for you too. But at this point, the user will not interact with the smart contract, right? It's completely based on what you want to achieve. In this case, this use case I'm describing is the user logins with the web auth or auth. It will work also if you have a mobile app. You get the user to log in using the biometrics of the phone or whatever, and then you interact on this behalf with the contract, right? So you always need an AOA. We in this case you are just having an AOA that you control, and since the AOA doesn't pay any gas because it's in the silo or it has a deal, it will be simpler, right? But you at the end you need an AOA. I'm just That's the meaning of abstraction. It's not account AOA elimination. The AOA is there because the that's the how the EVM works, right? You need the AOA, right? But you create a level of abstraction on top of that account. So you abstract some of the functionality into other things, right? So the user doesn't have to sign. I will abstract it to OAuth or something like this. So that's how the general idea of this is. As I said before, that's I said at the beginning, there are many ways you can implement this. Ethereum, I like the Ethereum way, but then you need to wait until there are enough bundlers, and the bundlers will have some control. At the beginning, there will be a few, so it's centralized, etc., etc., etc. And then it will be cheaper for the user, but not necessarily cheaper for you as a game developer because you have to pay the bundler, right? The bundler is not doing this. It's like it will be. I haven't seen a bundler working, but I understand they will need incentive to do this. So it will become a fee on top of the validation or whatever the gas fee where you're doing. So you will have to pay the bundler to do this. So it could become a little more expensive for you as a game developer. With Aurora, what we're doing is a similar approach, but we are giving you a number of free transactions, right? On top that, Aurora transactions are really cheap, right? But on top you can have free transactions, so you pay less for your users, and that instead of paying fees gas per transaction, we pay. That's a gas, but if you look at the Aurora Pass, Aurora Plus, you will get zero gas transactions. That's something you can get, right? And if you get a Boris business deal, you probably get even cheaper. It won't be free, but it will be very cheap. Or you can say, no one that interacts. You can probably don't abstract entirely. You just allow some interaction for the user, but the user pays zero gas. You can say with Borealis business, you can say for this smart contract in specific, none of my users will pay gas. So you can say that I will pay for them, but they don't have to pay. You can simplify some aspects like no gas. You can simplify both access those aspects of no gas and no MetaMask interaction. You can do both, right? Yeah, and also, well, the silo is it's not a side chain, but it's a basic idea. But it's a similar idea. But yes, it's better. Uh, and also, what I was about to say, well, about Rena's business, you can set the rules so you can make it cheaper or and simpler to do this, and then you decide what you want to pay, what you want the user to pay. This is what we've been rolling the past few months, the Aurora business. Yeah, but then you need to think your contracts. Now you have free transactions. So what I'm going to do with what kind of contracts? That's one of the things we want you to explore in the hackathon. Now, what kind of contracts you will create? What kind of abstraction or flows you can create if your user doesn't have to pay any gas? This is part of what we're thinking about. This is my approach, right? But this is definitely not the only approach, and probably it's not the best approach, right? Probably someone coming a better idea. Oh, but you should be doing this or that, or just sign the user. Probably I I did this in the past. In the past, the user will. I was trying to replicate the subscription model, so you get the user to to pay you, I don't know, $10 a month for playing your game, right? So you get the user to sign you 12 transactions, and you go each month and pay, and then the rest you pay the gas for them. So you don't mind a per transaction. I don't know if I explain myself. I charge the user once a month, and if she transacts once, or she transacts 1,000 times, I don't care. They pay me $10 a month. I just use account abstraction to charge them every month. I create that. You have to create that contract, right? It would be something like this wallet contract. You have to create a wallet contract that allows you to charge them a specific amount each month, right? So what you probably away is you when they subscribe, they sign you 12 transactions, right? And you every month your backend go and runs the transactions each month, and then you don't have to worry like if it transacts once or twice or 10,000 times. You don't have to worry each time to go what happened with this user. So that's another approach, right? So that was Visa was trying to achieve, and it's not that hard. It's not that hard with a smart contract to get a monthly subscription model. So yeah, you can think of that, yeah, like a pattern of gas. So that's the general idea. Yes, we are thinking this for creators, right? So we understand that a lot of your users won't be Web3, proficient. They might understand where with MetaMask, but they don't necessarily have the funds in MetaMask all the time. Or there are many issues of getting traditional gamers or traditional users to use Web2. So we understand that, and we're trying to make it easier. So look at we created the silo for the hackathon. It's free transactions. So think about this. Think about what kind of flows will you implement if you have users that pay no gas. How you can make it better. How you probably implement a kind of abstraction so they don't have to even never look at MetaMask or an address. The way I like to think about is an ideal Web3 game would make it not necessarily to the user to use MetaMask or even deal with blockchain, but if they want to, they should be able to do it. So the standard user can just go and web out traditional user and password, but if they want to go to the next step, they want to get the address of their NFT or stuff, they should be able to do it too. So it will be like the best of both worlds. If you don't want to know anything about the blockchain part of the game, fine. But if you want to go full on, you want to know the address, you want to trade your NFTs, whatever, you should be able to do that too. But that's a challenge. It's not, I don't think it's it's simpler from the UX part, but it's possible. That and my idea, it's my opinion, right? Is I think that will be the best possible game. So yeah. So we are way past time. So I think thank you for the questions. Again, you have my Telegram, my Twitter, whatever. I repeat again, I never ask you for money or your account or nothing. So please don't fall for it. But you can always ping me there, and any questions, suggestion, we can see your code or whatever. I probably will have some office hours. Whatever I can do to help, let us know.
Amazing. Thank you so much, Boris. And absolutely no, we appreciate all the information and all the wise words you can give us on this hackathon. So thank you so much as well for this incredible workshop, and a lot of interesting things said right towards the end. Some interesting ideas to think upon in this hackathon. So yeah, incredible stuff on this workshop. But again, massive thank you to everyone who's joined us today, and again, a massive thank you to Boris and the Aurora team for again another incredible workshop. So amazing. So yes, I hope everyone has a lovely day. I hope you all had a lovely weekend, actually. But thank you again for joining us this Monday. But as Boris said, please do connect with either us or on Boris on separate different kind of channels. We really do want to help. Keep us updated. Let us know if you're facing any problems or if you have any questions regarding about the hackathon in general. We are more than happy to help. But yeah, I hope you all have a lovely day, and thanks so much again, everyone. Bye.
Okay. Thank you. Bye.